Alright guys, so this is going to be a project we'll be working on for the next couple of weeks, and it will count as your final exam grade. So make sure you're spending lots of time and putting in lots of effort so you get a good grade on this for your final exam. So Miss Dunson recently came to the science department to enlist your expertise. She needs to know the relative pH levels of the soil across campus. To do this, we'll be running experiments to fulfill her request. It is up to you to develop a process by which you'll be doing this. There are several steps that we'll need to go through for our findings to be accurate and reliable. So here they are. First is background research. We need to learn about what we're getting into. We'll investigate our topic and become highly educated on the subject. That way we're competent scientists. We need to know what it is that we're talking about. So this will be a 4-page paper in the end, and it will discuss all of your findings for your background research. So here's some guiding questions, and again, these are just suggestions to help you get started and get you in the right mindset. Think of yourself as a teacher, and you're explaining everything you think a student might need to know in order to understand the experiment you're going to perform. It's not a question and answer type of paper. It's a normal research type paper, but you kind of have to guide your own thinking and the questions that you'll be answering. So these are a few to get you started. The first would be like, what is pH? Do we know what pH is? Do we have a good enough understanding to be going out and testing the relative pH and to know what it is exactly that we're looking at? What makes up the soil? If we know what makes up the soil and if we know pH, maybe we can take some guesses at what the relative pH might be before we ever do a test. What influences soil pH? How does the pH of soil influence what can live and grow in it? So if we can look at the sort of vegetation that's growing in that soil, and we know that this type of grass prefers a pH that's somewhere in the range of 6, then more than likely, if that patch of land has that particular grass growing in it, then the pH might be 6. So again, these are just kind of guiding questions to get you thinking, what sort of information do I need to know to be able to perform this project, to develop an experiment and be knowledgeable about what it is I'm doing. So again, this will be a 4-page paper. It will be double spaced though, meaning there's a space in between each line of your pages. There's a document on Schoology that goes over MLA format. That's the format you'll be using. So again, there's a document there that you can reference to help you understand how your paper should be formatted. Doing your research, we're looking right here, you will be using reliable resources only. That means you're not going to any website that ends in .com or Wikipedia. So what you can use is any website that ends in .edu, .org, or .gov, or better yet, you can go to Google Scholar and read scholarly articles from that resource. You need to have a minimum of 4 resources. You will also have a works cited page at the end of your paper that will list all of the sources you used. Next will be developing your hypothesis. So every scientist develops a hypothesis that states exactly what it is they're testing. This sometimes comes in the form of a question, but more commonly is written as a statement. An example would be something like the noise pollution generated by air cannons in the Arctic Ocean disrupts the migratory patterns of local cetaceans, resulting in the dislocation of cetaceans during the winter months where they starve, impacting the cetacean population. So this is an example of a statement type hypothesis. So we can look here. This hypothesis shows us that whoever is doing this experiment is testing the effect of noise pollution on the population of cetaceans. That's whales in general. So you will develop a hypothesis after you've done your background research, because you can't develop a good hypothesis until you're somewhat educated on the topic. So you'll develop a hypothesis and you'll turn that into me, and it'll be due via Schoology, or done via Schoology. Once you have done your background research, developed your hypothesis, you'll go into experimental design. So here you will design every aspect of your experiment. Exactly how are you going to go about determining the pH of the soil? What materials are you going to use and what procedure will you follow? And remember, every good scientist shows consistency in the data they collect. This means each sample needs to have the experiment run on it multiple times. This must also include a written step-by-step procedure. You'll also need to be sure to include every material you're going to use. Everything from lab equipment, beakers, spoons, water, um, literally just everything you're going to use. If you're going to use water, I need to know exactly how much water. You're going to use 100 milliliters of water. All right, fantastic. What's that water going to be in? So you need to tell me what that water is going to be in, as well as that you're going to use 100 milliliters of water. So just exactly, literally everything that you are possibly going to use and touch throughout this experiment needs to be listed in your materials list. You'll also, again, write this step-by-step procedure. So you'll think exactly how you're going to do this experiment and write it out. So your step-by-step procedure will be turned into me, as well as a list of all the materials you're going to need. That's going to help you be organized in the experiment you're going to do. That's also going to help me know what kind of materials you're going to need so I can aid you in getting those things. And then you'll execute your experiment. You'll do it. Then finally, you'll have your conclusions. So you'll look at what were your findings? What factors do you think influenced the pH of your samples? Or why do you think that they were so similar if they were similar? And to answer some of these questions, you might think about where the samples were collected from. So if they're collected in areas that are really similar to one another, then you might want to consider what's similar between them. Maybe that similar thing is what is causing them to have a similar pH, or if they're very different, what's around that might be dictating that pH. So you'll write out your conclusions, and this will be in the form of a poster board. So on Friday, the May 26th, we as a whole science department will be doing a science expo, sort of like a big science fair. So you'll have to present on your experiment. So you'll have to have a board that tells us a little bit about your background information, the hypothesis that you came up with, what your experimental design was. So how did you do your experiment? And then also the bulk of it will be your findings, the conclusions, what data you collected from doing your experiment. So again, this is going to be for your final exam. So make sure you put in plenty of effort. Today, the next few days, your focus will be on this background research section. Okay, so you will be forming your own direction of your research. So you'll be thinking about questions, anything you think might be relevant to understanding the experiment you're going to do, include. And again, don't write it just like a question and answer type of thing. It needs to be a formal looking and sounding type research paper, as if you are teaching somebody they had no idea what any of this was. You need to be able to explain it to them. Again, check the MLA format document on Schoology, and hopefully you don't have too many questions and everything goes well. Good luck.